All right, so we're going to go over our unit review problems from this first unit so that we can have a test tomorrow, right? So the things that you are going to want to, the things you're going to want to know about, and I'm going to make sure that I give you guys the same list that I gave the other group. Oh, man. All right, you're going to need to be able to identify independent and dependent variables. You're going to need to be able to draw a graph. And your graph is going to have your dependent variable on the y-axis and your independent variable on the x-axis with units. You're going to need to be able to write an equation. And for your equation, you're going to need to make sure that you identify what x and y represent. What values slope and BR with units. The x and y should also be with units. And know the shapes of graphs and relationships between x and y. So those are all the things you're going to need to know for the test tomorrow. All right, so you guys ready to talk about the review? Okay. So up at the top here, I know I write in this big markery pen. A force is needed between the tires of a car and the road in order for the car to turn. The force needed depends on three variables. The force is directly proportional to the mass of the car. The force is directly proportional to the car's speed squared, and the force is inversely proportional to the radius of the turn. Refocus that. So these questions aren't about actually doing anything with forces and radius and velocity. This is about, can we look at these things and figure out what the equations and relationships ought to be? And so I like to rewrite these as something that looks more like an equation. So up here, my force is going to be proportional to the mass. Force is going to be proportional to speed squared, and force is going to be proportional to 1 over the radius of the turn, because when something is inversely proportional, it means we're gonna flip it over into a reciprocal. Does this make sense to everybody? Do you have questions about this? It's just making math senses, right? So part A says, if the mass of the car is doubled by adding passengers and cargo, by what factor must the force change so the car can make the turn? So if we know that force is proportional to mass, and we're going to double our mass, that means that we're also going to have to change this other side so that proportion stays the same. So we're going to need to also double the force on the other side. So you could write this as 2F. You could write double the force, as long as it's clear to me that you understand that we need twice as much force to move twice as much mass. Okay. If the speed of the car is doubled, by what factor must the force change so the car can make the turn? So we said that the force was proportional to speed squared. So if we double the speed, what's going to end up happening is that we've got 2 times s squared, which is 4s squared, right? So if we go from s to 4s squared, if we go from s squared to 4s squared, that means we're going to need 4 times as much force for this to balance. How are you guys doing on these so far? Okay? All right, next, if the radius of the turn is doubled, by what factor must the force change so the car can make the turn? If force is inversely proportional to the radius and the radius is doubled, what's happened is now we've got 1 over 2r. And so for this to stay the same, we're going to have 1/2 the force. So it's only going to take half the force if the radius is doubled. You guys might have experienced this, maybe in a car, maybe in a roller coaster. If something has a really wide sweeping turn, you feel less pushed down into your seat than if it's a really tight turn. You guys ever notice that? It feels a little bit different. You can actually get an app that can measure that force on your phone. The problem is that to test it, you have to kind of set it on your lap for the roller coaster. That's risky, right? We don't really trust our forces that much. All right, at the end it says write a single equation relating force, mass, speed, and radius based on the proportionalities given above. All right, so we said that force was proportional to mass, force is proportional to speed squared, and force is proportional to 1 over r. So when we say it's proportional to, that doesn't mean that we don't have other things that are involved. And so what we're going to do here is just relate force with these other variables. Okay, so watch this. We're going to just combine these. If I combine them like that, are all of these still true? If speed and radius stay constant and I change the mass, it's still proportional to force. If radius and mass are constant, force is still proportional to speed squared. And if I keep mass and speed constant, force is still proportional to 1 over r. How'd you guys do on that page? Does it make sense now? Yes,
On the
Natalie.
last one, can we have it multiplied by 1 over r?
Yeah, I mean, you could rewrite this a bunch of different ways. That would work. Some people really don't like the reciprocal, and every once in a while I have a student write this. Which is the same. Anyway. All of these are the same. Okay, you guys ready to move on? Next, guitar. Anybody play guitar? Ukulele? Stringy, plucky things? Yeah, so you guys have you've probably done this experiment. No? Okay. I got my daughter a ukulele. Admittedly, I was trying to move her away from the recorder, which is a fine instrument, but But one of her favorite musical artists plays the ukulele. I was like, look at her ukulele, and then she'll play the ukulele all the time instead of the recorder. So now she's a 6th grader and she's joined the band. So yesterday I bought her a clarinet, which she's extremely excited about. So here's hoping. Of course, she doesn't. She's kind of like, well, why couldn't I just keep playing the recorder?
Well, I thought the recorder was sweet. I liked it.
I still have mine.
Yeah, you can play it with your nose.
It's a good place to start. All right, so our guitar here. A student noticed that thicker strings on the guitar. A student noticed that thicker strings on a guitar produce lower notes. She measured the thickness of the strings and the vibration frequency of the string when plucked. So this sounds like an experiment, right? So the thing that she changed is going to be our independent variable. The thing that she was changing was the thickness of the string. And then in response to that, she measured, which is going to be our dependent variable because it depends on the independent variable. The vibration frequency, I'm going to write vib, freq, pitch of the string. She tightened each one to the same tension, and then plucked each string while measuring its pitch with a computer. It's probably a pretty solid way to do that. So first, what's the relationship being studied? The relationship being studied is going to be the relationship between the two variables, our independent variable and our dependent variable. Here we've got thickness of the string and vibrational frequency or pitch. So we've got string thickness and string tension. Nope, that's not those. Vibration frequency and pitch. No, vibration frequency gives you your pitch. How is the thickness affecting vibration frequency? Those are our two variables. Or how the string tension affects vibration frequency. This was constant, right? She said she always tightened this to the same thing. So that was being controlled. So our answer here should be C. On the test when you have multiple choice, I'll accept either writing it on the line or circling it, or you can do both. I only get confused when they don't match, which happens every once in a while. So just look out for that. Next, what's the dependent variable? Well, when we sketched this up here, we said the dependent variable is a vibration frequency because it's what she was measuring in response to the change. The independent variable was the string thickness. There it is. Which was something that she was measuring and then measuring the vibration in response to that. And then lastly, things that need to be kept constant. And there might be more than one. So do we need to keep the string tension constant? Yes, we do, because that's a variable that could change what we're seeing. Vibration frequency, that's not something that we want to try to keep constant because we're measuring that in response to the thickness. The length of the string that's free to vibrate, that would probably change our pitch some. That's why when you play a guitar or something that's got strings like this, you put your hand in a specific place because that allows you to control the length of the string. So we're going to want to control that. String thickness, again, that was one of our variables. Pluck technique is probably important. With experiments like this, could you imagine that your technique might change if your hand got tired? So you're going to want to be careful about that. So if I was writing this online or to ACE. By the way, don't try to do like some crazy complicated thing with these. If it's a multiple choice on a test, usually if you get at least one of them right, I'll give you a half point. Well, that's not necessarily true. Yeah, I'll give you about a half point. If it's clear that you selected them all just to see what you would get, don't do that. Try to be specific. Yeah, so it's not like this question is worth 3 times as many points because it has 3 answers in the slot. Okay. Any questions about the guitar frequency thing? No? Okay. All right, so one thing that you are going to need to know is what relationship goes with which graph. And this is right off of that handout. A couple of these are pretty straightforward. I'll give you guys a couple of tricks too. All right, I like to find the ones that I know first. Right? So this first one, number 6, says y equals kx. I expect this is a straight line that has a constant slope. That's not 0. So that's going to be E. I already know E. Number 8 says y is independent of x. It means y has nothing to do with x. It's always the same. So I'm going to pick A for that one. The one that I feel like I'm most comfortable with of these, the curvy ones, is the one in the middle, C. And this is y equals x squared. So C goes there. Y versus 1 over x, that's this inverse relationship. It's the one that kind of scooches down into the corner there. That leaves one left, B. One way that I convince myself that that's the right one is that if I wanted to straighten that one out into a line, grab a pen. If I wanted to straighten it out, I could do that if my y values for every x were larger, right? I want to make this bigger. One way to make it bigger is to take this y value and square it. That would make it much larger. And that would change it proportionally. Like down here, the change would be small, but as I went along the line, it would get bigger and bigger. So that's one way that I convinced myself that that's the right choice. You guys have any questions about these? This is just memorizing stuff. All right, number 11. We've got a graph. It's given us our slope and our intercept, so that's convenient for us. All right, so the first question, explain the meaning of the slope value minus 0.50 as it pertains to this problem. Well, one way to look at this is to start with what my units ought to be. If it's 0.05, it's negative, so it's losing something. It's going down in y value. My y value is milliliters. Sorry, my y units are milliliters. My time is hours. My problem here says the graph shows the amount of water remaining in a graduated cylinder as time passes and the water evaporates. And so what it appears is that this is telling us that the graduated cylinder is losing 0.50 milliliters per hour. That's how fast it's drying up. We know that it's losing because it's negative. If this was a positive number, we would say that it's gaining water at that rate. Next is write an equation for the graph, inserting the variables and constants as appropriate. And don't forget your units on these, guys. And so the way we're going to write this is in our slope-intercept form. So if you, by the way, if you don't want to write volume and time and orbital, whatever the axes are, if you want to give these symbols, you can do that. That's okay. So I'm going to write volume in milliliters because I need my units is equal to my slope minus 0.50 and then my units, milliliters per hour. I like to put my units in parentheses. Times time measured in hours plus my intercept, which was 8.00 milliliters. What does 8 mean? What's the significance of that intercept? Natalie? Yeah, it started with 8 milliliters, and we know that because that was when time is 0. So this is sort of the conditions at the starting point. When we started our experiment, we had 8 milliliters. Isn't this, guys, do you think this would be like the most boring experiment to watch ever? Just sit there and watch it for an entire school day. Anyway, so next question says, determine how much water will be left at time equals 15 hours. You can use any method you want, but you have to explain how you arrived at it. By the way, you can use math to explain how you got it. I consider math to be language in here. So if you write an equation and you show your work, that's explaining how you did it. Does that sound fair? Okay. So being able to write an equation lets us predict the future, which is cool. One way we could solve this problem is we could draw this line all the way out to 15 hours and see what value it has. That would be tricky to do. Another way that you could do it is by making a data table. So you could make a data table and have 0 hours, 1 hour, 2 hours, 3 hours, 4 hours, all the way down, and figure out each of those values because we know how fast it's changing. Oh, guys, you didn't stop me when I did that. You guys see the mistake I made?
Yes.
Yeah, see, you guys, you can flag me. It's okay. I make mistakes sometimes. Did I make any other mistakes? I hope not. I wasn't trying to if I did. I did it right there, but not there. So you could make a data table, and you could start with 8.0, 7.5, 7.0. You could go all the way down. That's another way you could do it. Or you could use the equation. So I could set this up. My volume in milliliters equals minus 0.50 milliliters per hour times 15 hours plus 8 milliliters. Now, what's cool about doing it with this is if I keep track of my units, it'll tell me if there's something wrong with my equation. Because if I cancel out my hours, I've got milliliters equals milliliters plus milliliters. So my units work. So that can give me some confidence that my equation is correct. All right, so minus 0.5 times 15 should give us minus 7.5 milliliters plus 8 milliliters. So after 15 hours, I should have 0.5 milliliters left. Should be almost done. Did you guys get that? Okay, good. I'm like all concerned now because I made a mistake. All right. Anybody have any questions about this page? Was it a mosquito or a gnat?
I don't know.
I've caught one of each today so far. They're both dead now. There was a mosquito in my house last night too. I don't know what's going on with mosquitoes right now. All right, so I was waving this in front of the camera yesterday while we were chatting in class. So an important equation for electric circuits is power equals resistance times current. This looks like slope-intercept form. When I see something and it's this equals two things, that's one of the things that I kind of start thinking about. Is if I did an equation and I held one of these things constant, what would the graph look like? So an experiment is done where resistance is kept constant. So if something is kept constant, that's a clue that that's going to be your slope when you have something that's a straight line. The current is varied, so that's a variable. So this would be our I'm having a moment with this question now too. I might have helped you guys wrong yesterday. No, that's right. So if current is being varied, this is our independent variable. And the resulting power is measured. So this is going to be our dependent variable. Remember, our dependent variable is going to be y. Our independent variable is going to be x. This says label axes appropriately for such an experiment and sketch the shape of the expected graph. Now, the easiest way to do this is to say, okay, my slope is this thing that's being kept constant, the resistance. So that's why I wrote m by resistance, because it's slope. The current is being varied. So that's going to be my x-axis. And power is measured. That's my dependent variable. So I'm going to label that y and put that up there. I could make a table. I'm not going to. So if I identify that as my y-axis and I just put power there because it's coming right from my equation, and I take current squared as my x-axis, then I should get a straight line that describes the resistance. So this is one way that you can find resistance if you have a circuit and you can measure those other things. Now, if you want it to be power and current without the squared, what we're doing is taking a step backwards. This is thinking backwards from what we did in worksheet number 1. Do you remember worksheet number 1? We had the data table, and then we made a test plot, and then we linearized it. Here we're starting with our modified linearized graph and going backwards. So you could write this, and this would be one way that you can answer this question. If you're going to have a straight line, though, it has to be current squared. If you have a curvy line, it has to be current. What questions do you guys have about that one? Did you guys get that one right? And then it says in a second experiment, power is kept constant, resistance is varied, and current is measured. So in this new one, power is our slope. The resistance is varied, so resistance is going to be our x-axis, and current is going to be the thing we want on our y-axis. So we have to figure out how to rearrange our equation so that we can get that. You guys ready? How far did you get on this one? Does everybody have a guess?
Yeah.
Oh, cool. Okay. So if I start with power equals resistance times current squared, and I want to move things around so that I've got my slope and resistance on the same side. So what I'm going to do is divide both sides by r. So if I have p times 1 over r equals I squared, then I've got this set up. So this is going to be my y. This is going to be my x. This is going to be slope. Did you guys follow what I did here? This is the original equation that we had up at the top of the page. I rearranged it so I had current, so that I had resistance being varied and measuring current. And then I'm going to set this up with these axes. So current squared is going to go down at the bottom. Oh wait, that's not right. Current squared goes on the side. Over here, my x is 1 over resistance. And then my straight line is going to be power. This one's a mess, right? That's what I would go with. I wouldn't try to go backwards and set it up so it's just current and resistance. Ethan.
Wait, so were we supposed to graph the straight line or just the
I would just graph the line. What did you do? Because you'd have to modify it 2 times.
Okay, so we didn't have to do that.
You didn't have to.
What would it look like if it was modified?
I'm not sure. Because you'd have to unmodify it, right? So if it's squared, so okay, so if we have 1 over x, it would look like this. So if we did current squared versus resistance, it would look like this. If we did
That's the inverse, so would it be like curved outwards?
the inverse, yeah, see that's the thing, is we need to do it twice. It's kind of like, So then if we squared, we had y squared. So this is our y squared relationship, right? It would kind of like flatten it, but this is so different than that. I'm not sure.
Why is it 1 over?
Because in order to get resistance on the same side of the equation as power, we have to divide both sides by resistance. And so it would be the same as if you wrote it like this. Because we're dividing both sides by r. And so those two would be equivalent. Either p divided by r or p times 1 over r. I'm not going to give you anything that's hard tomorrow. This is kind of like, see how much harder it could be? But we're not going to do that. We're going to do something simpler. All right, what questions do you guys have? Yeah, this too. No. Expect something like this, and you don't have to go backwards. Expect something like this. Expect something like this. You know, like you have a graph and you're asked questions about the graph. Expect exactly this. Wink, nod. I know, right? I'm trying to set you guys up here. Expect something like asking what relationship is being studied, independent, dependent variables, and constants. Any other questions?
Oh, I have 3.
All right. That's all I have for you guys today.
No, I don't think so. I'll do a TED Talk tomorrow.
Oh,
No.